Good morning, afternoon, whenever you're watching this. We are in week 4, geometry, equations of parallel and perpendicular lines. If you made it this far into the class, congratulations. You only have this week and next week to finish everything up, and those 2 weeks are gonna fly by. If you got into this point and you still have some work to turn in, as in you're like, I forgot to turn in some stuff for week 3, by the time you're watching this video, all the work from weeks 1, 2, and 3 should have already been turned in. If you try to turn in something from week 3, unless you've talked to me already, I'm just gonna zero out. I'm not gonna give you any points, so don't bother working on that. If you missed 1 or 2 assignments last week, just work on stuff from week 4 and just try to turn it in before Sunday. All right. Okay, we're at the end game here. Slope. We're gonna go over 3 things. We're gonna go over slope, slope-intercept form, and point-slope form. Slope is the measure of the difference between the position of 2 points in a line, right? The best way I can describe that is, we got 2 points on a line, and the distance between them makes that line what it is, right? That is slope. Slope is rise over run. It's usually shown on a coordinate point. I hope all this stuff is sounding familiar to you, right? Because the slope part is just it's just kind of the review, right? So then we have slope-intercept form. Again, slope-intercept form is y is equal to mx plus b, and it tells you how to graph a line on a coordinate plane where m is the slope and b is the y-intercept. If you're wondering what a y-intercept is, it's just wherever the imaginary line you're trying to graph touches the y-axis, that point is called the y-intercept. All right. This is all stuff from algebra, so I don't know how many of you guys remember this. So I'm just going to explain a little bit of what it is first, and then we're going to move on. What you're going to be doing, though, however, throughout this entire thing, the key part here, and I want you guys to write this vocabulary down, point slope form. It looks weird, right? It says y is equal to y1 minus m parentheses, which means times, x minus x1 close parentheses. This is the equation you're going to be using. Make sure to write it down. And it is used to find the equation of a line that is either parallel or perpendicular to another line, as long as you have the slope of the first line and a set of coordinate points. These are the conditions of the problems that you are going to be doing this week. And you're going to be doing it in this way. Before we go into this, I just want to review these 2 things right here, right? These lines, you should know that these lines are parallel lines, right? And you should also know that these are perpendicular lines, and they have certain properties, right? So if you think back and you remember from a couple weeks ago, parallel lines just means that the lines have the same slope, right? Another way for saying slope is the m value, and this is going to be very important because we're going to use the m value in all the equations. So if the first one has an m value, it has a rise of, let's say, 1, and a run, right? I don't know if you guys remember this. Rise, it goes up by 1, and it runs to the right by 1. This one, if it's parallel to it, is going to have the same thing. It went up by 1, and it ran to the right 1. Because they're both rising by 1 and they're running to the right by 1, they're never going to touch. They're parallel lines. Those are the conditions of parallel lines. Perpendicular lines, on the other hand, have a different problem. As you guys know, they do make a 90-degree angle, but we're not really concerned about that this week. What we're more concerned about perpendicular lines is something called the negative inverse, right? In terms of m value, perpendicular lines have something to do with m as well. Let's just call this line A, and let's call this line B. So if right, line A has an m value of, let's say, 1/2, right? Then line B has to have an m value that's a negative, that's a negative reciprocal. What that means is that the fraction, right, and I'm going to explain this later, the numerator and the denominator switch places, right? So line B, if line B is perpendicular to line A, then that means that its M value, its slope, becomes 2 over 1. And the sign switches. Since line A has a positive slope, right? We're just going to say, I mean, I know it doesn't match there, but if it has a positive one, then line B has to have a negative one. If line A happened to have a negative instead, negative M value, then line B's value would be positive. And the fractions are always going to switch places. Now, you might be thinking, well, mister, what happens if I'm given just like a regular number? What happens if M is like 4 or something? How can I flip the reciprocal? Well, if M is equal to 4, 4 is a whole number. You can make 4 into a fraction by just putting a 1 under it. Then the other one, the negative reciprocal, is going to be negative 1 over 4. So you always have a fraction, even if they don't give you one. You are going to have to deal with fractions. So I'm going to have to show you how to handle those. All right, you guys got this? Okay, good. We're going to move on. All right, let's review slope really quick. Slope, again, is equal to m. If you're ever run into an occasion where you're not given the slope, but you're given 2 coordinate points, like if they give you a graph and there's a line and you can kind of tell where 2 coordinate points are, what you're going to have to do, like for example, this problem, let's do this practice problem. Find the slope of the line that crosses points 3, comma, -3 and -5, comma, 5. But the first thing you're going to have to do before you even look at the formula for slope, right? You're going to have to label. Now, I'm going to have to label one set of coordinate points x1 and y1, and the next set of coordinate points x2, y2. That doesn't mean squared, by the way. That's not like x squared. No, this is x2. This just means that it's the second coordinate point. It's my second x, and this is my second y. And the other one's my first x and my first y. Does it matter which one you label which? No. No, it doesn't. The only thing that matters is that the ones stay together and the two stay together, which means that if you label 3 and -3, x1, y1, that's fine. If you wanted to label them x2, y2, that's fine, as long as the other one is the other one, okay? And now you'll see what I mean by that right here. This right here is, in case you didn't know, the slope formula. Go ahead and write this down if you don't have it. Slope, which is the same as m. M is equal to y2 minus y1 over, it's a fraction, or divided by, right, x2 minus y1 divided by x2 minus x1. Sorry, I might have said that wrong, but you can see it in front of you. So what this means, right? Sorry, that's a y. That's not a 1/2 or anything. That's a y. Okay. So what this means is now that I've labeled my coordinate points, I'm gonna just replace the values with the ones that I've labeled, right? So right here, I'm down here now. M is equal to, and my y2 in this case was +5, so I put a +5. Now I put this first negative here because look, this fraction has a negative. So the equation already has a negative. Then you're going to put it in parentheses, the next thing. The reason why you're going to put it in parentheses is because take a look at y1. Y1 happens to be a negative number. The negative from the negative number is separate from the negative of the equation. That's why that's why I put it in parentheses, and that's why there's 2 negatives present there. And that's important because it's going to change the sign. Okay, cool. I have my top set up. What about my denominator? What about the bottom of my fraction, right? Okay, so my x2 happens to be -5. So I put -5 minus, and my x1 is a +3. Notice since it's a +3, I don't have to do this. I don't have to like put a positive there, but I can if it helps. I mean, I personally don't, because what ends up happening is you're still subtracting, and the negative and the positive still makes a negative, right? Just like the negative and the negative on the top will still make, that will become a positive. So if you notice from here to here, the negative and the negative multiply together to give me a positive, and I have 5 plus 3. On the bottom, I have -5 minus +3. A negative and a positive just makes a negative, which really means I have -5 minus 3 is really what it is. And that's kind of like saying -5 you owe someone $5 and then you borrow 3 more from them, that's subtracting 3 more, your debt goes up to $8 now, which is why we have a, -8 down here. Okay, 5 plus 3 would be +8 on the top, right? We're jumping on here now. +8 divided by -8, which gives me a -1. This has a slope of -1. Okay, so what that implies is on a graph, if you have a line that has a negative slope, it's gonna look generally like this. It's gonna like start on the top here, and then it's gonna go down. It implies a line that decreases by 1 every time, and it moves to the right by 1. If you had a positive slope, it would look like that. Negative slope, it looks like this. Okay? Just keep that in mind. All right, now let's move on to the actual lesson. This was review. Okay, finding the equation of parallel lines. What you're going to be required to do is you're going to see a problem that looks like this, right? At the very top, I have the problem written. I wrote, write the equation to a line that says hat. It's supposed to say that. That is parallel to line y is equal to 5x plus 1 and passes through point -1, 2. Man, I just cannot spell today. All right, so those are going to be your conditions. What that's trying to say here is, remember, the key here is this word parallel lines, right? We have the first line, right? We have this first line, and it is currently being represented by this equation, okay? This equation represents this line. I don't know, I'm just making that line up, right? 5x plus 1, okay? What we want is, we don't want the first line. What we want is an imaginary second line, right? We want a second line. We want this line to be parallel to this line, right? And we want it to pass specifically through point -1, 2. We want -1 and 2 to be a point on this new line, right? This is the new line. And this is the old one. This is your original. We want to know what is the equation that represents this new line, okay? That's what I wrote here. Note, what's going on is you already have a line represented by that equation. Your job is to find an equation that is a parallel line that also goes to -1, 2. What you also need to remember is that because they're parallel lines, they have a relationship already, right? If you guys remember what I said in the first slide, parallel lines means that they both have the same slope, right? M1 is going to equal M2. What that means is the slope for my first line has to be the same as my slope for my new line. So before I do anything, I already know that since this is in y equals mx plus b form, I know that my slope for line 1 is going to be 5. And if my slope from line 1 is 5, my new slope, my new m, the m I'm going to use is going to be 5. If they say parallel lines, just use the same slope. How do I know what my slope is? Well, you see this right here? Whatever number is attached to the x in the slope intercept form, which is the slope intercept form is this form, it's y equals mx plus b, is going to be your m value. Your m in this case is 5 because 5 is in front of the x, okay? Okay, that's a lot of review. All right, so how do we actually start this? We're gonna use point slope formula. Remember that formula I told you way back, like this one? This thing, the one that I have a star next to that says y minus y1 is equal to m times x minus x1. You're gonna be using this formula a lot, okay? That's the main formula you're gonna be using. The first one, the y equals mx plus b, is a form. It's kind of like a form that everything needs to be in, but you're gonna use the other one, right? You're gonna use the other one a lot. Okay, so we're gonna start with that, right? We're right here. We're right here, and we just step 1, start with point slope formula, right? Just write down the formula. Y minus y1 is equal to m times x minus x1. Always start there. Okay, cool. Step 2, substitute what we know. In this case, because they're parallel lines, and I cannot stress enough, if the problem in the beginning says given, and it says that they're parallel lines, the m value is the same. And you find the m value by looking at the equation that they give you, and it's whatever is in front of the x, okay? So you have m is equal to 5, right? And if m is equal to 5, then your new line, your m value is going to be 5. So that's why I have m is equal to 5 here. My x1 is going to be from the point that they give. Remember how I said that it has to pass through -1 and 2? Well, -1 is going to be my x1, and +2 is going to be my y2, okay? That's where I'm getting these numbers from. They're not coming out of anywhere. They're coming out of what's given. You're always going to be given something, some piece of information. So here I'm going to substitute everything in here. So if you notice, oops, it's supposed to be a 1, right? My y1 is 2, which is why I put a 2 in parentheses. It's important to put them in parentheses because if that's a negative, you don't want to have just one negative there, because there's a negative from the equation. If that 2 happened to have been a negative, I would have needed to have put parentheses there to make sure that I remember that that's going to switch signs. But since this is a positive, it's not. It's going to just stay at a -2. It's going to be y minus 2 is equal to 5 times x. Notice how the regular x stayed an x, but I replaced x1, which is the second one. X1 is a negative, so that's why I put it in parentheses. And as you can see, there's 2 negatives there. Okay, cool. I have everything set up, right? What do I do now? Well, I move on to step 3. Simplify and distribute 5. Now, the 5 is outside of the parentheses, which is why I have those arrows, because what that's saying is I have to multiply 5 by every single thing on the inside, okay? And if you notice, I got rid of the parentheses in front of the y minus 2. Since 2 is a positive number and I have a negative in front of it, it just becomes y minus 2 is equal to, and then I have this 5 times x. They just kind of get together, so that's 5x, right? And then the next thing, 5 is going to multiply by that 1, right? Which is why I have a 5. That's where this 5 came from. But then I have a negative and a negative. Negative times a negative gives me a positive, which is why there's a positive there. That's how I figured out that whole thing. All right. Okay, now we're going to move on to step 4. We're going to have to isolate y by inverse operations. If you remember what inverse operations means, it just means I want y to be by itself. If you're starting to notice, this equation is starting to look like the y equals mx with b form, and that's a good sign. That's what it's supposed to look like. But first, before it looks like that, I got to get rid of that 2. Since it's a -2, I'm going to add 2 to it, to both sides. So I can cancel out this 2. I add the 2 to the 5 because I can't add the 2 to the 5x, but I can add it to the regular numbers. And then I bring them down here. Y is left on the left-hand side by itself, which is equal to 5x just comes right down, plus 7. Okay. I put a box around it because that is my answer. That is the equation of the line that is parallel to equation y is equal to 5x plus 1, and goes through point -1, 2. Now, do you notice something about my answer and the original equation I used? I hope you notice that they both have 5 for the m value because they're parallel, so they have to have the same number there. And the only thing that really changed was the b value, right? The second number, the one is plus 1 and the other one's plus 7. These 2 equations are implied to be parallel, and they just have a different starting point is really what's going on. Okay, so let's move on to perpendicular. All right. Okay, let me just do this one thing. Okay, so perpendicular lines. A couple things I gotta emphasize here about perpendicular lines. They're not the same as parallel lines. Okay, they're just not. Right here, the problem is asking us. We're right here, right? The problem is asking us, hey, can you write an equation of a line that is perpendicular to my line -2 divided by 5, which is a fraction, to -2 over 5, x, plus 12 and passes through point -6 and -8. Okay, this is a different situation. Like this means that they're perpendicular. So something like this is going on. There's like a little cross or something going on, right? And then, right, we have a line that's a -2, 5. What that means is it starts at 12, right? This is 12. The y-intercept is 12, so there's a dot on 12. And it goes down by 2, right? So it goes down, let's say this is 10, and it goes to the right 5. So let's do this as 5. If you notice, my line, right, which is, this is the equation, and it represents this. And since it's in y equals mx plus b form, I was able to graph it. My line is going down. And I want another line that is perpendicular to this, so it's going to look something like this, right? Because it has to make a 90-degree angle. And it has to pass through points -6 and -8. -6 and -8. So it's going to be way down there, right? Okay, how am I going to find the equation of this new line? Well, the first thing is what I have here, this whole thing on the bottom. Under the note, it says you have to realize that perpendicular means that two equations will be each other's negative reciprocal. That is a very important term, negative reciprocal. And that means that you can't use the same m value for both equations. In the last example, we had parallel lines and they were the same. I was like, if they had, whatever your x is, you're going to use it for the union one. Here, we can't do that anymore. No more. Whatever our x is, our m value, right? Our m value here is a fraction, is -2/5, right? That's for my first equation, which is why I'm going to do this, m1. My second equation needs to be the negative reciprocal. And what I mean by negative reciprocal, it means that the numerator and the denominator have to switch places. That's what reciprocal means. Reciprocal just means that the denominator and the numerator switch places. So my m1 is no longer 2/5, sorry. It's actually 5, it's actually 5/2. The numerator and denominator switch places, but that's not enough. I want the negative reciprocal. And since my original is negative, negative times a negative will be a positive. And that's how I end up with this, right? This is my value for my second one, okay? Now, what you need to understand about this, right, is that there's another rule too. How, because you might be thinking, okay, how do I know if I did it right? How do I know if I have my, how do I know if I did it right? You know, how do I know if I have the correct one? Well, you have to understand, that this m value for a new line has another rule to it, right? If it really is my negative reciprocal, what's going to happen is that I should be able to multiply my original, which is this one, to my new one. And when I multiply the fractions across, they're going to end up becoming -1. What I mean by that is -2, right? When we're multiplying fractions, numerator multiplies by numerator. -2 times +5 is going to be a -10, right? And 5 times 2 is going to be a +10. Now, we have -10 divided by +10, we end up with -1. That's why I have a check here, because it checks out. If my original m multiplies by the negative reciprocal of itself, I should always get -1. And that lets me know, that confirms that that is the perpendicular slope, okay? Now that we know what the perpendicular slope is, we can always do the rest. Now we can actually start the problem, right? That whole thing was a setup. It's really important for you to not forget that whole thing. Now that we know that our new m is +5/2, let's plug it into point slope formula. And remember, our point is -6 and -8. It has to cross that. So that's gonna be our x1 and our y1, okay? Now we're gonna do the same steps we did last time with just a small, tiny twist, right? So we're gonna start with the point slope formula. We start with this, we're right here, right? We start with that, and then, hold on. We start with that, and then we move on to step 2, which is to substitute m is equal to 5 plus all that. X1 is going to be -6, and Y1 is going to be -8, because those were our point, okay? So with that, right, we just plug them in, right? Y1 is going to be -8. I'm going to put it in parentheses because that's a -8. So there's a negative in there, and there's a negative from the equation. 5/2 is going to replace the m. And inside the parentheses, -6 is going to replace the x1. You always replace the second one, not the first one. We want to keep the regular x and the regular y until our final equation. Next, step 3, simplify/distribute 5/2. That 5/2 is outside the parentheses. It needs to be distributed, which means it needs to multiply by the x. It also needs to multiply by that 6, -6, whatever it is, right? So let's go ahead and do that. The first part right here, right? We know that a negative times a negative will be a positive. That means y is equal to +8, right? Is equals 5/2 times x is just going to be 5/2x. They just kind of combine. Plus, and here's where it gets a little tricky. I'm gonna do 6 times 5, because whenever we're multiplying a fraction times a whole number, the numerator multiplies by the numerator. This whole thing is really 6/1, right? So 6 times 5 is 30, and 2 times 1 is just 2, so we end up with 30/2. And we have a negative and a negative. We have two negatives again. So we have two negatives again, that becomes positive, okay? All right, so that's a little confusing. Step 4, what do we do next? We're gonna convert 30/2 into 15, because really what that fraction is telling me is that 30 divided by 2, and 30 divided happens to go into 30 can be divided by 2, and you're going to get 15. So what I have here is I'm also going to isolate the y, meaning that 8, right? Since it's positive, I'm going to subtract 8 from both sides. That's why I have this. I'm going to cancel out. I'm going to move it over to the other side. I have y is equal to 5/2x. I'm going to leave that alone. Plus 15. If you're wondering where I got the 15 from, is just 30 divided by 2. Minus 8, right? And I just broke this down into a separate step just so you know that, I'm not pulling these numbers out of nowhere. Now, my final answer is y is equal to 5/2x, which, is just my slope, plus 7, because 15 minus 8 is going to be +7, okay? And that is the equation of the line that is perpendicular to my original, okay? That is my answer, all right? Okay, we're almost done, guys, I swear. This is the last thing here. I was looking through some of the problems I'm gonna make you guys do, and I noticed this one, and it's not hard. You just have it, but it is subtle. You have to understand a couple things about what they're asking you. Find out if lines are parallel on a rectangle in a coordinate plane. There's a question on there that is saying like, hey, what if we had a rectangle on a coordinate point and it looked like this, and we wanted to know the slopes of all the lines, right? Now, obviously the rectangle could be diagonal, and that would be a different story. If the rectangle was like a diagonal, like kind of like a diamond shape, right? If it looked more like this, you can 100% use the slope formula, and you can find the slope of all these lines, because all these lines have slopes. However, if you have a rectangle exactly like this on a coordinate plane, you're going to find two interesting things that happen here, right? Vertical lines like AD, right? Lines that go straight up and straight down actually have a slope that is undefined. And horizontal lines, straight horizontal lines, that means the line that goes from left to right and doesn't rise at all, actually has a slope of 0. How do I figure this out? Well, I'm going to use the slope formula. Remember how I showed you guys the slope formula from earlier? Well, in the slope formula for AD, right, I use the slope formula here from earlier. And I have my coordinate points here. I used, if I'm not mistaken, let's see, I used this to be my x1, y1, this to be my x2, my y2, right? So my y2 was 1 minus 3 and 1 minus 1. And I ended up with minus 2 divided by 0. And you cannot, under any circumstances, divide by 0. The first time my math teacher, when I was young, taught me this, they said, you just can't do that. You just memorize that rule. And they never told me why. But the reason why you can never divide by 0 is, imagine if you have 2 apples and then you have to divide them by nothing. That statement doesn't make any sense, because you'd look, if I asked you to divide the 2 apples that you have by nothing, you might be inclined to say that, well, I just don't do anything to them, right? Like, I can't divide by 0. I don't do anything to them. Well, not necessarily. You can't divide by nothing because the statement doesn't make sense, right? To divide something means you're going to have to cut those apples up. And the number on the bottom, the denominator, tells you how big I want those slices to be. Your slice cannot be 0 because that implies that you have no slices. That implies you didn't divide, but the fraction says that you have to divide. So that statement is a contradiction. And it's impossible to do. So that's why you can never divide by 0. So AD, we're just going to write, whenever you see like a vertical line that's perfectly straight, like this, it's undefined. The slope is undefined. You don't have to do it. But if we have a line like AB, right? AB is different. AB ends up being 3 minus 3, which is 0, divided by, oops, that's supposed to be 2, I guess, divided by 2. And that's different because that's like saying, hey, I don't have any apples. And I'm like, great, divide nothing by 2. And you're like, okay, I just did it. And you like pretend to cut something. You're like, yeah, I just cut nothing. And you end up with nothing because you started with nothing. So it's 100% possible to divide 0 by a regular number, and you're going to get 0 every time. That's actually possible to calculate. So AB, a perfectly horizontal line with no rise, has a slope of 0. A perfectly vertical line has an undefined slope. Okay. So hope this helps. Good luck, guys. And once again, email me if you have any problems. Send me comments. I'm a little swamped with comments over this weekend because a lot of people are turning in work. But I'll get to you as soon as I can if I haven't already. All right. See you guys.